Okay. Variation. What is the meaning of this word?
Is it like, so there's inverse, no, indirect, was it proportion, variation?
Yeah, so it's the same thing, but that is in mathematical terms. So if I talk about the dictionary meaning of variation, what is it?
I don't know.
So it's a change, varies, changes, right? So in this topic, basically we are discussing about if one increases, if one of the term increases, what is the effect of that increase on the another one? If that one would be increasing, that's the direct variation, or we can also say direct proportion, right? And if x is increasing and y decreases, so that's a inverse proportion or inverse variation. This is the basic idea of what this topic is. Okay. So can you tell me any example where both the terms are increasing?
Maybe if someone is traveling at a high speed, then his distance will also be increasing.
So you are saying speed and distance, correct?
Yeah.
So if speed increases, distance covered will also be increases. Okay, but do we have anything which can change this relation? For example, I'll just give you one example. Let's say speed is 50 miles per hour. Okay, do you use miles or kilometers?
I use kilometers.
Kilometers, okay. So speed is 50 kilometers per hour. Distance traveled is 100 kilometers. But here, oh, 1 minute, what happened? But the time is 2 hours. Okay. Now speed increases. Let's say it is 80 kilometer per hour. But we have only 1 hour. So will this distance increases or decreases? I made it a little difficult. Just try to understand what I'm trying to say here. Here you said speed and distance are directly related. Now I'm saying speed is increasing. Will the distance also increase, keeping this thing in mind?
So it's going faster and the time goes slower. Wouldn't the distance just stay the same?
We don't know, right?
Yeah.
See, the formula for distance is speed into time. Are we aware of this? Yeah. So 50 multiplied by 2 is 100. Absolutely right. 80 multiplied by 1 is 80 kilometers. Correct? So that means when speed is increasing, distance is decreasing. Earlier it was 100, now it is 80. But you said speed increases, distance increases. So what is the factor that is changing your answer?
Oh, so time is the factor that changes distance.
So let's take time constant, which was in the first case. I'm taking it 2 hours in the second case. Now, what would be the distance?
160.
160. So distance is also increasing now. So whenever we are saying speed increases, distance increases, we have this background that time remains constant. If time is not constant, we cannot tell the relation, whether it would be increasing or decreasing. It can be anything, right? So there is always a third factor, Amrita, which remains constant. Okay? Is it clear, or do you want me to give one more example?
Can we just do one more example?
Yeah, sure. Anything in your head, I can take that example only.
Let's say 40 kilometers per for what was it? Are we doing speed first?
Anything. You can take any other example than time, speed, and distance.
I had an example, but I don't know where it went. I'm trying to find it now. I don't know where it went. Can't think of anything right now.
It's okay. So let's say, I'll give you one example. Just figure out what is the relation between them. Number of people and work done. What is the relation between these two?
So like the amount of time it'll take to get the work done, or how much work?
How much work? How much work?
So if there was an increased number of people, then more work would be done. So
yes, but again, what if the time is less in the second case? Will the work done increase or decrease? Can we comment on that?
So if the number of people increased and
let's say I'm taking one example. So 20 people, let's say they are making 30 baskets. Okay. And now the number of people are 40. So you will say that 60 baskets, because this is also getting doubled. This will also get doubled. Easy. But the point is, it should be mentioned in the question that time we are taking in both the cases, Amrita, has to be constant. Because if time would be different in both the cases, then we don't know whether it is going to be doubled or not. Okay, just tell me whatever is going in your head. Just tell me.
I can see that it'll take longer.
Yeah.
If double the amount of people made 60 baskets. And I can also tell just between the numbers, because there's 20 people who made 30 baskets and then 40 people who made 60 baskets. So there's so it was like the difference between 10 and 20, and it slowly increases.
Yes, it is increasing. What is the doubt here? Or you got it?
I think I don't know.
See, whenever we are taking two terms, the third one has to be constant. Is this thing clear? Because I gave you example here. If time will not be constant, Amrita, like 2 hours here and 1 hour here, the answer, what you said, wasn't coming out, right? You said speed increases, distance increases, but that's not happening here because time wasn't constant. And when I took time constant, when I took 2 hours in both the cases, the distance was also increasing when speed was increasing, right? So the main point, the crux of this whole thing is, when we are taking two things and checking their relation, whether direct or inverse, there is always a third thing that has to be constant. Okay, that's all about this topic. Now, let's do one question from what you have shared. Okay, it's I think first exercise, page 5. I'll just tell you if you're facing any doubt or something. Question number 1. I don't know which page it is in your book, but this is, I think, 801.
801. One sec. Okay. So write a variation equation for D.
Yes.
So if the distance. So the equation to find D would be D times like K times T. So that would be, so using the first line, 190 times K times 1. So K would equal 190. So the equation would be D equals 190 times T.
Yes, absolutely right. Correct. How far in kilometers will Craig run in 20 minutes? Okay, so we have one specific case, 20 minutes, and the second one is of 45 minutes.
So I got, so 190 times 20, it's 3,800, but we have to put it in kilometers. So, no, sorry, meters. We have to put it in meters.
Meters, yes. This is in meters, and we have to convert it into kilometers. Because as you can see the table, in the table, distance is in meters, right? So the answer which we got here is in meters. You have to convert it into kilometers. And how do we do that?
Is it divided by 1,000?
Yes.
So 3.8.
3.8, absolutely. Okay. And similarly, we can find for 45.
Is it 8.55 kilometers?
8.55 kilometers. 8.1, yes, absolutely right. Correct.
for C, how long it would take him to run 12.35 kilometers.
Yes.
It would take him 1 hour and 5 minutes.
1 hour and 5 minutes. Have you converted into meters firstly?
It'd be 12,350 over 190 to get the time, which would equal 65 minutes. So that's 1 hour and 5 minutes.
Absolutely right. Okay, any question which you want to discuss from the first page, from first 1 to 5?
No.
All clear. I think they're very similar. From the second one, from question number 6 to 9.
Okay, so 16.
Are you aware about how to find the gradient of a line?
Wasn't it rise over run?
Yes, correct. So in the question number 6, we have E part as gradient. You want to try this?
Yeah, we'll do the gradient. Okay, so is the gradient 7.5 because it's 15 over 2? Like the
I'll just check. So it's 4, 30. And another point, you can take 2, 15. So 15 over 2. 7.5, right? You're getting 7.5, Amrita?
7.5.
Yeah, correct.
How is it related to the constant of variation?
See, for that, you need to find the equation. From there, you will get it.
Oh, okay. Wait, I'll just fill out the table first and then I'll try and do the equation.
Yes.
I can't tell if that's a 7 or like 750 in the graph.
For which one? For 1?
Oh, yeah, for A. 1A.
Yeah. It's I think exactly in half, in between 5 and 10. So 7.5. For 2, it is pretty clear. It is.
And then 3. That'd be like 2350 as well. 23.5.
Yeah, it's in the middle of 20 and 25. So we will take 22.5. The equation that would be formed from here would be?
So cost times something times the amount of burger.
Cost equal to?
Cost is equal to K times H.
Correct. And what is this K here?
Hold on.
It's the same as it was in the previous question. Like there was a gap of 190 in every case. Remember this?
So hold on. I'm just trying to write it down. It'd be 750 times blah blah blah. So the equation is C equals 750 times H.
750 or 7.5?
Oh, I'm looking confused. Just 7.5.
Wasn't the 7.5 the slope?
Yeah, it was 7.5.
So this is the relation. That's what they're asking. How is it related to the constant of variation? So constant and slope both are equal, right?
Wait, can you just
Constant and gradient both are equal. Can we say that? Because the equation which you got was C equal to 7.5 times H, and gradient was also equal to 7.5. So how is it related to constant? It's equal.
Okay. Oh.
Yeah.
How is it related to the constant? Okay, I got it.
Let's do question number 8 and then we will move to next exercise. Okay. If you have any questions, Amrita, just tell me. We'll discuss those.
I'm mixed up. I didn't know what constant meant when it said how is it related to the constant of variation?
K is the constant. K is the constant, right? So they're asking the relation of gradient with K. And they came out same.
Constant was different, right?
Constant was different.
Oh, sorry, no, like if the constant was different, if it was different.
Then they won't be asking this question. Because if you have done linear algebra earlier, so whenever we have a line, whenever we have a straight line graph, the gradient is always the coefficient of x. The gradient is always the coefficient of the variable. And same thing is happening here. This is nothing but gradient only.
Okay.
That's why they have asked this question, because they're related, they're equal.
Okay.
Question number 8. Just read the question. If you want to do, you can do. If you have any questions, you can ask.
The mass of the car and its consumption rate. Okay. So it says find the equation for f. So would it be f equals k times m, or would it be m equals k times f?
A linear relationship exists between the mass of a car and its fuel. Okay, so you can frame any of these, it doesn't matter. Both of them are correct.
It says find the variation equation for F. If a 1,000 kilogram car uses fuel at 6 liters per 100 kilometers. I don't know how to do A. It's not making sense.
So you are taking F equal to K times M or M equal to K times F?
I did M equals K times F.
I'm doing both of them, so you can recheck. We'll be getting the same answers. It's just that a constant will be on the other hand. That's all. So I'm putting the values the way you use it. M equal to K times F. So M is 1000, K is K, and F is 6, right? So we'll get the value of K as 1000 over 6, which is 500 over 3. Right, so we will put it back in the equation and we get the equation as M equal to 500 over 3 times F.
Oh, okay.
We use the same method which we were using earlier.
Okay. So
now they're asking, find the fuel consumption of a 2500 kg car. And yeah, one more thing, as I told you, you can even frame this equation. It's up to you. So it's the same thing. I have substituted F as 6, M as 1000. So we got K as 6 by 1000, which is equivalent to 3 over 500. So I'll put it back. So F equal to 3 by 500 times M. These two are same. It's just that if I take 3 by 500 over there, it will become this.
okay, I'll do B.
Yeah.
So would it be this 100 kilometers?
Which one you're using? F equal to 3 by 500 times 2500? Can we say that for the second part?
Yeah, I use that for.
So fuel consumption is going to be 15 liter per 100 kilometer.
Yeah, I got that.
Do you want me to redo it or is it clear? I cannot hear you properly. Is it clear?
It's good.
Okay, okay. Let's move to inverse proportion. Any example of inverse proportion?
Pardon?
Any example of inverse proportion?
An example. Is decreasing, yeah.
Your audio is lagging a bit.
Oh, I don't know what's happening. One sec. Is it working?
Yeah, better.
So inverse is like when one increases and one decreases.
Yes.
So,
One increases, other decreases.
oh.
Okay, I'll give you the terms. You have to tell me how they are inversely related. I'll give you three. You have to figure out which one is inversely related. Okay? Okay, out of these three, only one of them is inversely related. Which one it is? Other two are directly.
So it's not speed and time.
Is it direct or is it inverse?
I think the speed and time is direct.
Can you give me an example?
Like the one we used before. If it was going like, sorry, I'm just trying to.
Take your time.
Just I'm guessing the inverse proportion would be the distance and time.
Let's say if distance covered is, okay. Let's say if you have 2 hours and if you have 4 hours. So you're saying in this, let's say if we are covering 20 kilometers, in this time we would cover less than 20 kilometers?
Oh, never mind.
So if we have more time, we can cover more distance. So this one is direct relation. Second one, what about work done in time?
So if you've made like, what was it, 30 baskets in 1 hour.
Okay.
And it took you 2 hours to make 60.
That means again direct.
So that means speed it. Oh, I chose that one first.
You have to explain it. Why? Like, give an example like this, the way you gave for work done in time and distance in time.
So like, say you were going 80 kilometers an hour, and it took you 1 hour to get there to your destination. And if your speed increased to like, I don't know, maybe 100, it would take you less time to get to your destination.
Like 40 minutes or something. Okay, yeah. Yes. The speed and time are inversely related. And in this, the constant will be 1 upon. For example, sorry, not constant. Constant will remain same. So this is the way we put when we have inverse relations. Speed is inversely related to time. So we put 1 upon. And if we have to expand it, it will become k times 1 by t. Earlier, what we were using in distance, work is equal to k times t. Distance is equal to k times t. But here, for the inverse, it would be speed equal to k times 1 over t. And this is the way to figure out the equation of the that question. Okay?
So 1 over t.
Yeah. So let's try one question. Acha, have you seen this sign before?
Yeah, I've seen it.
The sign of proportionality. And when we remove it, we put equal to along with the constant every time, whether it is for direct relation or inverse relation. Let's do question number. This is exercise 802. Question number 2. Let's do question number 2.
Okay. The rate of a vibration stream. The rate of a vibration on the string varies inversely as its length. A string that is 8 centimeters long. Your BC would be 12 centimeters.
What is it?
For question 2,
yes.
The length of the string would be 12 centimeters.
12 centimeters? Absolutely right. Correct. You want to discuss the method or is it clear?
I think it's clear. Yeah.
Okay, choose any one question, whatever you want to discuss or do.
I'll do question 1, the very first question.
Okay.
Okay, so for 1A, the variation equation would be T equals 120 over S. Sorry.
T equal to 120
over S.
over S. Okay.
Yeah.
Is it 120 over S, Amrita?
Yeah, because the questions, hold on. The question said, the time taken T hours to travel from Sydney to Melbourne varies inversely with the speed S kilometers per hour. And it said if it takes 11.5 hours at an average speed of 80 kilometers per hour, find the variation equation for T. And so I did T equals K over S, where you replace T with 11.5. So 11.5 equals K over 80. And to find K, you times 11.5 and 80, which is
1.5 instead of 11.5. Solve it.
11.5, sorry.
What will you get after multiplying these two? No, it can't be 120. It has to be a bigger number.
920.
Yeah.
Okay. Let's answer in hours and minutes. So 10 for 1B, I got it take 10 hours and 20 minutes.
10 hours? 1 minute. It got minimized 1 minute. For the second part, if the average speed is increased to 90, how long will the journey take? So 920 over 90? What is your answer?
I got 10.2, so and then it's have to put hours and minutes.
Yeah. So 10 hours, and for 22, you can just divide it by 60. 36 minutes, approximately. C part is easy.
Yeah, so it'll be 9 kilometers per hour.
Yes, correct.
Yeah. I think that's good now. I think I've gotten it.
Let's try question number 5. Or whatever you want to, because we have to do all the questions. So wherever you
do
like it looks tough, we can do that. Which one?
We'll do 5. 5.
5, okay.
It'd be B. Y equals 5 over X.
Y equal to
5 over X.
5 over X. So we put X as 2, we'll get 2.5. We'll put X as 5, we'll get 1. Yes, correct. Next question. 8th.
Yeah, I was just looking at that one.
Yeah.
8. Okay. Each graph shows an inverse relationship between A and B. Find each variation equation. So the inverse, the variation equation for A would be B equals 8 over A.
B equal to 8 over A. So if we put A as 2, we'll get B as 4. If we are putting B as A as 1, B. Yes, good.
And then for B, the variation equation would be B equals 100 over A.
B equal to 100 over A. Okay, let's check. 100 over 5, 20, 100 over 10, 10, 100 over 20, 5. Very good. Nice. Any other questions from this part, from this exercise you want to try?
I'll do 10.
Okay, go ahead.
Why? For 10A, 1/16.
Can you please repeat? Your voice broke.
Sorry. So for 10A, it would be y equals 1/16.
Y equal to 1/16.
16.
1
1
6.
6. Yeah.
Times x. Or you're telling me the answer of y when x is 32.
That's the answer I got.
Okay, got it. I thought you were telling me the equation. What is the equation that?
So the equation was y equals 2/x, and then it said find the answer when x equals 32.
Y equal to 2/x.
Yeah.
Okay. Yes. Correct. Okay. The next one which you shared with me is page number 16 of the PDF, and this is an equation. This is an exercise, and I don't know what exactly the topic is. This.
Let me just check on my laptop. Page 16.
Page 16. Yes, this graph shows a cyclist's journey on a training ride.
Yeah, that one. I don't know what happened to the other pages. Hold on. Oh, they were all just like extra information. Those 6 pages.
Okay.
No, hold on.
So in the first question, they're saying, let's just discuss what is the name of this exercise, if you can tell me. Like first one was direct, then we have inverse, and the third one is for?
This one is distance time graphs.
Okay. It says this graph shows a cyclist's journey on a training ride. Describe the journey of the cyclist, giving the speeds at each state. Do any interval of the graph indicate that the cyclist is traveling at the same speed? The gradient of the interval is EF is -30, but the speed at this stage. What does the negative gradient indicate? You want to give it a try or discuss directly?
Yeah, I'll give it a try.
Okay, go ahead.
Well, let me just... Okay. Describe the journey of the cyclist and speeds at each stage. So he starts and then he
When,
Start
when he's taking 1 hour, what is the speed?
20 kilometers per hour.
That's the distance, yeah, and the speed will also be. So it's up to you. You can even convert the graphs information in the form of table and then find the speed. Like you know that distance, sorry, you need to find speed, right? Speed is distance over time. So let's say, let's make a column for distance, one for time. So when time is 1, 2, 3, 4, 5. 1, 2, 3, 4, and 5. So when this time is 1 hour, distance is 20. So speed will also be 20, 20 over 1. When 2 hours, again it's 20. So this would be,
Sorry, hold on.
yeah.
So if the distance was still 20, would the speed also be 20?
Taking 2 hours and the speed is, yeah, it would be 10, no? 20 over 2.
Oh, okay.
Yeah. And when the speed, but we are calculating per hour, like from 1 to 2. That means 1 hour. Just a minute. Then it should be 20. This is the gap of 1 hour we are taking, right?
Yeah.
And this,
And then, so the hour between 2 and 3, his speed is 30.
logically, Amrita, in this case, what is happening, if you'll see the graph, from 1 to 2, from 1 to 2, the distance is same. That means, is he traveling? Distance is not covered from first hour to second hour.
Oh.
It is same as it was in the first hour. So what speed would be there?
Hold on. So can you just explain that to me again one more time?
Yes. So basically, let's say you came from school to home, okay?
Mm-hmm.
And then whatever speed you have here, that is, let's say x. But then you, for the next hour, you are staying at home only, right? For the next hour, you are staying at home. That means, so let's say this is for the first hour. For the second hour, you are at your home only. And that means you have traveled the same distance which you have covered from school to home for the next hour also, because you are not traveling further. So that means you were at you were at rest, and when you were at rest, your speed is, you're not moving. So what is your speed in that case? 0. That should be done. Because distance is same. You are not moving any further from first hour to second hour. That's why speed is going to be 0.
Oh, okay. Okay. So and then the next hour, the distance increases to 30 kilometers.
Yes.
And then he stays there for like 30 minutes until so that means he's reached his destination in those 30 minutes because his distance goes down. Is that it?
In this fourth one, it's 30, and for the fifth, okay, it's at 4.5 only, not even 5. 1 minute. At 4.5, the distance is 0. Correct?
Yeah.
Okay, so for the third case, when the distance is 30 and time taken is 3 hours, what would be the speed?
So on the third hour, he just rests. So wait, sorry. For the fourth one, I'm pretty sure it's also 3.5 because he's not like exactly at 4. He like rests till 3:30.
Yes.
So his speed would be 0.
Speed would be 0 in this case. And what about in this case? The third one?
Would it be 30 as well?
So what is happening here? He traveled 10 kilometers from 20 to 30 and he took 1 hour, 2 hours to 3 hours. So what would be the speed? From here to here, he traveled 10 kilometers and he's taking 1 hour for that. So that means
10.
10.
Yeah.
And for the last one?
It's just 0.
0. But he must have traveled. See, no, it's not 0. Just understand the way we did the above one. He traveled 30 kilometers, although he's coming downward, but he's traveling 30 kilometers, right? From 30 to 0. And he's taking 0.5 hours, like 30 minutes. So 30 over 0.5, that would be 60.
Okay.
We are not taking what is happening here. We are taking what was the last one and then the next one, the gap. Just check it out again and I'll explain it to you wherever you're facing it out.
Wait, okay. So it goes up for 1 hour, stays there, goes up again. Okay.
Do any intervals of the graph indicate that the cyclist is traveling at the same speed?
At the same speed. I was about to say between the B and C, but that would mean that he stopped.
I have to correct one thing. Just a minute. I think I have seen the graph incorrect. This point, this is 3.5. Just check the graph again. Check the graph again. At E point, Amrita, E point, the time is 3.5, not 4. Yeah, my bad. So from here to here, it would be 0. But from here to here, so it won't be 30 over 0.5. It would be 30 over 1. This difference is of 30 and here it is 1. So it would be 30 kilometer per hour. Right?
Yeah.
In the question C, the gradient of the interval EF is negative 30, but the speed at this stage is 30 kilometer per hour. What does the negative gradient indicate?
The distance?
The distance, that is 30. But distance can never be negative, no?
Oh, the speed that he traveled at.
They're asking what is a negative gradient?
What does a negative gradient indicate?
Just look at the graph. Yeah.
The gradient of interval EF.
The cyclist is again coming back to his original position. True?
Yeah.
He's coming at rest, right? At E, he covered 30 kilometers. But from E to F, he's covering 30 kilometers, but he's again coming back to his original position. That's why it is negative, because of the downward sloping. See, there are two cases. I'll just explain. Amrita, we are doing it for the first time. It might look confusing, but when we'll do the next question, it would be pretty clear in that case. So there are two cases. One is line like this, upward sloping line. Another is like this. Okay. This line is upward sloping, where gradient is positive. This line is downward sloping, where gradient is negative. Right? So the line from E to F is something like this only. It's coming from the top left and then going down. Right? Whereas from A to B and then C to D, they all are upward sloping where gradients are positive.
Oh.
Yes.
Okay.
Got it. That's why it's negative. So negative gradient indicate that it is coming back again to the rest and it's a downward sloping.
Okay. Oh, sorry. No, it was my mom. She told me to turn the light on.
Wow, yesterday also you turned it off. Don't like turning the light.
Okay.
Let's do the next one.
Yeah.
Okay, now you will try it.
So for the trip down the mountain, what was the speed of each skier? Why am I?
Okay, what was the speed of each skier?
So for Kate, I did
Total time taken is?
So it took her 9 minutes.
9 minutes. Total distance traveled in 9 minutes?
1,200 kilometers.
1200 by 9 is the speed of Kate. Similarly, speed of Colleen.
So speed of Colleen would be 1,200 over 10.
Over 10. Over 10.5, I think.
Oh yeah, 10.5.
Yes. Who reached the base of the mountain first and how many minutes did it take her?
So Kate
Okay.
reached it first, and it only took her 9 minutes, where Colleen took 10.5.
Yes. How many minutes later did the second skier arrive?
1.5.
How far had Colleen gone after 6 minutes?
After 6 minutes, Colleen had gone. It's almost 700, maybe 680, 690.
Yeah, 690 approximately. Yes.
Yeah.
How far ahead was Kate after 6 minutes?
After 6 minutes. Hold on. So Kate. So if Colleen was that much, Kate, would it be 110?
Yes, because it's approximately 800. We can see.
Hmm?
Yeah. If Colleen and Kate were skiing down the mountain, why do the graphs go up?
Because their speed is increasing as well as the time. So like,
Yes, so time is increasing, speed is increasing, and they're starting from the same point. We'll be traveling 1200. Yes. That's all.
Oh, that's it.
Yeah.
Okay.
Want to try third, fourth? Which one you want to?
Third. I want to try the third one. It looks hard.
Describe the journey represented by each distance time graph. Okay, so it's a theoretical question. You need to explain, like, if the graph is like this, for example, so what is happening here? Like, initially the distance traveled is less, then it is constant, and then it is increasing, like this. This is time on the x-axis, this is distance on the y-axis. So you need to understand the graph, and then you have to explain, you have to describe it, what is the pattern that we are following here.
So his speed, he starts increasing his speed. So like he starts it fast.
Mm-hmm.
And then he slows down because like what's the word?
It's like flat. It's a flat one.
It's more like flat line, and then he increases it again because the graph goes up.
So it's sloping upwards, so that's why its speed is increasing. Similarly, you can do for B, like it is sloping downwards. The speed is increasing, but the whatever we are taking, it is sloping downward. The gradient is downward, right? And then again, it's flat.
Yeah. So he started fast, but then he slowed down, and then he just stopped at a certain point. And then for C,
you can also mention, like in B and C, in question, in part B, you can also mention that gradient is, a negative, whereas in C, gradient is positive because it is sloping upwards. And even in A also, it is sloping upwards. So the gradient is positive. So while describing, you can also mention these words, these terms.
Okay. Oh, so for C, what the gradient would be positive because it's
positive,
going
yes.
upwards.
And then it is getting constant because as you can see, the graph is
line.
Yeah, speed is getting 0.
Okay, so for D, it's kind of like.
Do we have D options? I don't have it in
No,
my...
never mind. It's the same one. Never mind. It's only A, B, and C.
Yeah.
For match each statement to the correct part of the person slows down because he is almost home.
Match each statement to the correct part of the distance time graph. The person slows down because he's almost done. Okay.
A would be H, G, no, H.
A would be H, yes.
And then the person is not moving.
Hmm.
Is like the interval between C and D because
Yes.
it's like a flat line.
Correct.
After moving at a constant speed, the person increases his speed.
Hmm.
So like the E to F section, like F.
After moving at a constant speed, from D to E and E to F, it looks constant. But from coming from F to G, the speed is getting increased. Isn't it?
Okay, so it'd be F.
Yeah.
Is where he starts increasing it. E, after stopping, he increases his speed. That would be E because he stopped for a while and then he starts increasing it to go to F. Like after stopping, the person increases his speed.
What is the answer of D part? The person changes direction for the return trip.
For D, the person changes direction. Oh, hold on. The person changes direction for the return trip. Would it be F because he's slowing down to get to his destination? Okay. After stopping, the person increases his speed, which is E.
After stopping, that is D, no? At D point, and then he increases. Because from C to D, it's constant. The speed is 0. And after D, it increases its speed.
So it'd be D.
Yes.
The person gradually slows down. C?
Slows down can be C to D and even G to H.
Yeah.
G to H is also slowing down.
Okay. There's no more. So, which question now?
You tell. We have 7. Oh, it's almost time. Oh, I haven't seen the time today.
Oh, it's 6 o'clock.
Okay, so you can try the 7th and 8th part. Okay? 6th, 7th, 8th. And then we can start from the next part, which is graphs of change, 805. Let's do it tomorrow. And we'll try to finish it off. Then we will, then parabolas are there. So we'll try to cover that part tomorrow.
Yeah, okay.
Okay, do practice these. This was something different from what we discussed earlier. So distance time graph is something which you can do more. You can complete the exercise, and whatever doubt you will have, you can ask tomorrow. Okay?
Thank you.
Okay, bye-bye. Take care.
Bye. You too.